Hi guys, I hope you are all doing well. Let's see today's question. So today's question, we are taking it up from the topic of integration, and we are continuing our series of questions on JEE Advanced. So today's question, we have taken it up from the year 2009. And if you see the question here, it is told to us that In is an integral which has the limits from -π to +π. And the expression which is given to us is sine nx upon 1 plus pi raised to x into sine x dx. And we have been also told here that n can be 0, 1, 2, anything till infinity. So all the non-negative integers we have been given here. And we have been given 4 options. We need to check which of the options satisfy this question. So we have been told In is equal to In plus 2. Second option given to us is summation of m is equal to 1 to 10. I 2m plus 1 is equal to 10 pi. Then we have been told that summation of m is equal to 1 to 10. I of 2m is equal to 0. And the last option tells us In is equal to In plus 1. So let's figure out which of the answers are correct. And this is a multiple answer correct question. So there can be more than one answer is correct also. We need to check for all the 4 options and check out which of the 4 options satisfy the solutions. Let's figure out. So if I try to solve the integral first, I have been given In as integral of -π to +π sine nx upon 1 plus pi raised to x sine x dx. And this is told to us that it is valid for all the non-negative integers, right? So this is told to us. Now let's see. The idea I can use here is when I see the limits going from -a to a, I have one concept that provides me this, that says if I have -a to a with the integral of a function dx, I can write that as 0 to a, and instead of that function f of x, I can write that as f of x plus f of minus x dx. So this is the concept which we'll try to use it here. So In, instead of -π to +π, I can write that as integral of 0 to pi f of x, which is same, sine nx upon 1 plus pi raised to x sine x plus f of minus x, so that makes it sine of minus nx upon 1 plus pi raised to minus x and sine of minus x, the whole with dx. So now what I can use here is I can use an idea that says sine of minus theta is nothing but minus sine. So if I take that minus sign out here, let's see what I get. So In becomes integral from 0 to pi. The first I write it as it is sine nx upon 1 plus pi raised to x sine x plus the other expression. If you see, you get minus sine nx. So sine of minus theta is minus sine theta upon 1 plus you had pi raised to minus x. If you want to make it positive, you will take that as a denominator. And you have sine of minus x, which becomes minus sine x. So if I apply this idea, sine of minus theta is minus sine theta, I can see both of them has one minus sign, so I can cancel them out. So you get that again becoming positive. If you try to solve it further, you get 0 to pi. You can see sine nx and sine x is nothing but common here. So If I take that common sin nx upon sin x, what I get here left out is 1 upon 1 plus pi raised to x. And if I solve this expression also, I get 1 upon pi raised to x plus 1 upon pi raised to x. So you get this as 0 to pi sin nx upon sin x. This is equal to 1 upon 1 plus pi raised to x plus this pi raised to x, which is in the denominator of the denominator, will directly go to the numerator. You get that as pi raised to x upon 1 plus pi raised to x. This is equal to. So now you have this entire expression. If I try to solve this, I get in is equal to integral of 0 to pi sin nx upon sin x. And if you see this, I have the same denominator. So if I write those denominator only once, if I write that denominator only once, 1 plus pi raised to x. In the numerator, you have two expressions, 1 and pi raised to x. You add them as well with dx. These two terms get cancelled out and you are left with in being integral of 0 to pi sin nx upon sin x. So you get this as the value of in. So now we got the expression in terms of in as 0 to pi sin nx upon sin x dx. Now let's just check out which of the options are correct out of the four. So if I see the first one, it's telling me in and in plus 2 are equal to each other. Let's check that. So if I solve that, I know already that in is limits from 0 to pi sin nx upon sin x dx. If I also solve in plus 2 now, that will become 0 to pi sin n plus 2x upon sin x dx. When I want to prove this to equal, that basically means if I take the difference between the two of them, that should turn out 0. So let's find the difference of this. So if I see it is 0 to pi sin n plus 2x upon sin x dx minus again the limits from 0 to pi sin nx upon sin x. Now once I have same limits on both the sides, I can write that as in plus 2 minus in is having the limits from 0 to pi, and we are left with sin n plus 2 x minus sin x, so sin nx upon sin x. So I'm taking sin x common because it is the same thing present in the denominator. So it becomes 0 to pi sin a minus sin b. That gives you 2 times cos of a plus b upon 2. So it becomes n plus 2 plus n upon 2 x into sine of a minus b upon 2. So it becomes n plus 2 minus n upon 2 x. The whole thing divided by sine x. So if you see now, the difference becomes in plus 2 minus in is nothing but integral from 0 to pi. Here you get it as, so 2 cos of, it becomes 2n plus 2 upon 2. So 2n plus 2, so I can take out 2 common, n plus 1 upon 2 x into sine of n plus 2 minus n. So this gets cancelled, 2 by 2 becomes 1, becomes sine x upon sine x. This sine x gets cancelled, left with 0 to pi 2 cos of n plus 1 x. If you take the integral of this, cos of n plus 1 into x becomes sine of n plus 1 into x. upon n plus 1. We are dividing it by n plus 1 because it is the coefficient of x, and then the limits which are applied gives me. This becomes sine of n plus 1, or I should write 2 upon n plus 1, sine n plus 1 pi minus sine of n plus 1 into 0. So we already know, if I have 2 upon n plus 1 here, now we already know that sine of n plus 1 pi, sine of any integral multiple of pi, sine 0 is 0, sine pi is 0, sine 2 pi is 0. So sine of any integral multiple of pi is always 0. 0 minus 0 multiplied with 2 upon n plus 1. So from this expression we get that the difference of I n plus 2 and I n is equal to 0. And this gives me an idea I n plus 2 is equal to I. So from this, I understand that the first option which was given to me is a correct option. Right? So we get this as a correct option. Now let's see the other idea. So if I talk about the second option that was given to us, it says summation of m is equal to 1 to 10. I of 2m plus 1 is equal to 10. So if you put m as 1 here, it's going from m1 to 10. So you have 10 values of m. If you substitute m as 1 here, it becomes I3. If you put m as 2, it becomes I5, then I7, I10, I9, then you have I11. This goes on till the last value of m, that is 10. So it goes on till 20. So basically we have this 10 integrals for which we need to calculate the values here. Let's calculate. We already know In was 0 to pi sine nx upon sine x dx. So this was given to us. Now if I put here, let's say if I put here in, instead of n, if I put here 1, I get that as 0 to pi sine x upon sine x. So if I solve this 0 to pi, I understand this gets cancelled. You get integral of 1 dx and integral of 1 is x. Limits go from 0 to pi. That gives you the value of I1 as pi minus 0. Now once you get I1 is equal to pi, you also know one idea from previous that In plus 2 is equal to In. So if you put n as 1 here, you get the idea that I3 is equal to I1. So I3 and I1 being equal, I know already the I1's value is pi. So I3 also becomes pi. Simultaneously, if you put n as here, if you put n as 3, I5 becomes equal to I3. That is again equal to pi because we already know now I3 is equal to pi. So simultaneously, I understand all the odd multiples of I. So all the odd numbers, that is I3, I5, I7, I9, I11 till I21, all are equal to pi as a value. And when I want to find the sum of all of this 10 odd numbers of I, all of them are having a value of pi as the answer. So when all of them has the answer pi here, we get this pi added basically 10 times. So summation of m is equal to 1 to 10. I of 2m plus 1. So adding pi 10 times. And when you're adding pi 10 times, that makes it as 10 pi. So you are getting that second option also correct. That summation of m is equal to 1 to 10 for the odd values of I is equal to 10 pi. So this is also a correct answer. Now let's check for the even numbers of I because it's given us 2m. Let's figure out if that's correct or not. So if I see here, summation of m equal to 1 to 10, I have been here I to m. is equal to 0. Let's figure out whether it's equal to 0 or not. So if I put again m as 1, I get I2. If I put m as 2, I get I4, I6, I8. This goes on till I20. So I have now all the even multiples of this I, that is an integral. And we already know In is 0 to pi sine nx upon sine x. So if you just put value of n as 2, you get I is equal to I2 is 0 to pi sine 2x on sine x. If you solve this integral, you get 0 to pi 2 sine x cos x on sine x. This gets cancelled. You get 2 integral of cos x is sine x, and this values of limits are from 0 to pi. To solve this, you get sine pi minus sine 0. Sine pi is also 0, sine 0 is also 0. That gives me the answer as 0. So you get I2 as 0. And we already discussed in the first option that In is equal to In plus 2. Now if you put n's value as 2 here, you get I2 and I4 are equal. And since I2 comes out to become 0, I4 also becomes 0. Again, if you put n as 4, get I4 and I6 are also 0. So putting n value 4 here, so that also makes I6 0. Likewise, if you put all the even values of n, get all the even values of even multiples of I turning out to become 0. So when we had to find the sum of m is equal to 1 to 10 for I to m, that's equal to I2 plus I4 plus I6 plus I8 till I20. All of these even multiples are turning out 0. And when you're adding 0 10 times also, that's going to turn out 0. So again, if you see the third option, which was asked to us, find the sum of the even multiples of I for m is equal to 1 to 10. That's also turning out 0. So C is also the correct answer. Now let's just check for the D option. It's told us In should be equal to In. So let's check whether In and In plus 1 are equal to each other. So if I put n as 1, this gives me I1 and I each other or not. So let's figure out. We already calculated when n is equal to 1, we had I1 with us, that is pi, and I2, which we had in previous slide, we got I2 as 0. I2 turns out 0. And I can see and tell that pi and 0 are not equal to each other. When these are not equal to each other, I can definitely say I1 and I2 are equal. And from that, I understand that all the odd multiples were equal to pi, and all the even multiples of I came out to become equal to 0. So In and In plus 1, which are the consecutive values of I, are not equal. So the D option which was given to us that says equal to each other, that is not correct. So I understand from this example that there are three answers which are correct to this question, that are A, B, and C. So you need to mark all the three of them. I hope you have understood how to solve this type of questions of integration where they have told us an integral's value, and there are four options. You need to check for all the four options and pick the correct options. In this case, it works out for A, B, and C. And this entire question was based on this concept that said minus a to a f of x dx. You can write that as 0 to a f of x plus f of minus x. That gives you the answer. And then you check one option one by one. So you got A, B, and C correct, and the D is not correct. So we get the answers for the question as A, B, and C. So these are the three correct answers. I'll see you again tomorrow with some other question from some other topic. But we are going to continue our series of questions on JEE Advanced. Do like, share, and subscribe to my channel. Also, do share these videos with your friends who are also involved in the preparation of JEE Advanced, which is going to happen in June. So they can also take the benefit from this. Thank you.